Let's try to solve the following linear inequality. So here we have a rational expression 3 divided by x minus 2. So this is less than 1. What we'll do, we'll subtract 1 from both sides. So this gives us 3 over x minus 2 minus 1. Now we'll combine the two terms. This gives us x minus 2 in the denominator, and in the numerator we have 3 minus x plus 2. This is less than 0. Which gives us 3 plus 2 will be 5. So we have 5 minus x divided by x minus 2. So this is less than 0. Now if we multiply both sides with negative 1, so we will have x minus 5 in the numerator divided by x minus 2. But since we're multiplying with a negative number, so the sign of the inequality is going to change. This is what we have used a fact here. That means if we have a is greater than b and we have a number c which is negative, that means less than 0, then if we multiply a with c and b with c, then ac will become less than b times c. This is what we have applied here. That means x minus 5 divided by x minus 2, we have found out that this value is greater than 0. Now that immediately gives us two cases. So we have case number 1 and we will have case number 2. So let's talk about them individually. That means x minus 5 and x minus 2, that is divided by x minus 2. If they're greater than 0, that means they are positive. This would be possible if x minus 5 is a positive number and x minus 2 is also a positive number. When both of them are positive, so we're positive divided by positive, that gives us a positive number. And case number 2 would be, we could have x minus 5, the numerator, to be a negative number, and that means simultaneously x minus 2, the denominator, is also a negative number, and we know that negative divided by negative is going to give us a positive value. So these are the two cases. Now let's try to solve each of the cases independently. So first we have x will be greater than 5 and x will be greater than 2. Now we will consider a number line. On the number line we will have 0, 2 and 5. So we will first consider all the values of x which is greater than 5. That means it should lie to the right of 5. So these are all the values of x greater than 5. And we also have all the values of x which are greater than 2. So that means it's going to lie to the right of 2. Now what will be a common solution to this which satisfies both x is greater than 5 and x is greater than 2? So this is going to be this particular region. So that means if we have x greater than 5, then this is going to satisfy both the two conditions, that x is greater than 5 and x is greater than 2. Now we will come to the second case. So here we have x minus 5 less than 0 means x is less than 5, and x minus 2 is less than 0 means x is less than 2. So let's consider on the number line. So we have 0, 2 and 5. So we'll consider all the values of x which is less than 5. That means it's going to lie, the values of x must lie to the left of 5. And we also have x is less than 2. So we'll consider all the values of x which is lying to the left of 2. Now what is a common value of x that is going to satisfy both x less than 5 and x less than 2? So this is going to be this common region. The common region means that we have to consider values of x which is going to be less than 2. Now let's try to combine the solution obtained in both case 1 and case 2. So we will consider our number line. So on the number line we have 0, 2 and 5. So x greater than 5, it's telling us that we have to consider all the values of x which is lying to the right of 5, and we have to consider all the values of x which is lying to the left of 2. That means x is less than 2. So this is a solution, and if we want to write this in the interval form, then this will be, we'll take all the values starting from negative infinity going all the way up to 2. So this will be in an open interval. That's because 2 is not included. It's not a part of our solution. We have x less than 2. And negative infinity is always unbounded. Then we will also consider union. And we'll also consider the values starting from 5 and going all the way up to infinity. It's an open interval because x is greater than 5, meaning 5 is not included, and infinity is unbounded. So this is going to be the solution set to a given linear inequality.